All right, we hear the term air pollution thrown around constantly, but what does it actually mean? It's not just one thing. It's this incredibly complex soup of different particles and invisible gases. So in this explainer, we're going to pull it all apart piece by piece to really understand what's in the air we breathe. To really get this right, we have to start with the official textbook definition. And I know, it looks like a mouthful, but the key words in here are injurious and interfere. See, it's not just about the air being a little dirty. Pollution, scientifically speaking, is when there's enough of something for long enough to actually cause harm or mess with our lives. This idea is going to be our foundation for everything else we talk about. So, here's our game plan. We'll start with contaminants that actually come from nature. Then we'll get up close with something called aerosols, all those tiny particles floating around. After that, we'll investigate the pollutants you can't even see. And finally, we'll connect the dots and map these pollutants back to where they come from. Okay, so when you picture air pollution, your mind probably jumps to a factory smokestack, right? Or maybe a line of cars stuck in traffic. But believe it or not, the atmosphere had contaminants floating around long before we started building factories. Let's kick things off by looking at one of Mother Nature's biggest contributors. Yep, we're talking about pollen. It's basically the superfine, reproductive dust that trees, weeds, and grasses release into the air. The wind just picks it up and carries it for miles and miles. And, well, if you're one of the millions of people with seasonal allergies, you know exactly what I'm talking about. This stuff can trigger everything from a runny nose to serious asthma. So just how small are these little irritants? Well, we're talking about a range of 10 to 50 micrometers. Now, to put that in perspective, a single strand of your hair is about 70 micrometers thick. So these particles are smaller than the width of a human hair, and that small size is exactly what allows them to get deep into your lungs and cause so much trouble. All right, moving on from the purely natural stuff, let's get into our next huge category, aerosols. Now, that might sound like a fancy scientific term, but it's really just the name for any tiny solid or liquid particles that are suspended in the air. And this category includes a lot of the stuff we typically think of as pollution. First up in the aerosol family is plain old dust. What makes dust? Well, dust is how it's made. It's all about physical force. Think about rocks getting crushed at a quarry, or wood being sanded down, or even just wind kicking up soil. It's just big things being broken down into little things. No chemical change, just brute force. In the tiny world of aerosols, dust particles are actually the heavyweights. They're typically bigger than 20 micrometers. And because they're relatively big and heavy, gravity usually pulls them out of the air pretty quickly. But there's a big exception, stuff like fly ash from power plants. Those particles can be much, much smaller and stay floating for a very long time. Okay, next we have smoke. And this is a completely different beast from dust. See, smoke isn't made by physical force. It's the result of a chemical process. Specifically, it's what you get from incomplete combustion. When something like wood or coal burns without enough oxygen, it can't burn cleanly. So instead, it releases these tiny, solid bits of carbon. That's smoke. And this is where it gets really fascinating. Not all smoke is the same. Just look at the size difference here. Smoke from coal can be incredibly tiny, down to just 0.01 micrometers. Oil smoke particles are generally a bit bigger, and that size difference is absolutely critical because the smaller a particle is, the deeper it can get into your lungs and even into your bloodstream. That makes it a much more serious threat to your health. So we've covered the solid aerosols, but let's not forget about the liquid ones. The two big players here are mist and fog, and while they're both essentially just tiny droplets of liquid floating in the air, there are some really important differences in how they're made and how they act. So here's the breakdown. Mist is made of pretty large droplets, relatively speaking, and they're spread out. But fog is different. It's formed when water vapor in the air condenses into a really dense cloud of much smaller particles. And it's that density of tiny particles that's responsible for cutting down visibility. It's why you can barely see your hand in front of your face in a thick fog. This little table really pulls it all together nicely. You can see the clear patterns, right? Dust comes from physical grinding. Smoke and fumes come from chemical processes like burning or condensation. And when you look at the liquids, mist and fog, the biggest difference really comes down to particle size and how concentrated they are. It's a fantastic summary of all these different particulates. So, everything we've talked about so far, dust, smoke, even fog, are things that, to some extent, you can see. They make the air look hazy or cloudy. But here's the thing. Some of the most dangerous pollutants are completely and totally invisible. So, what are they? And that question brings us to our third major category, gases and vapors. These are fundamentally different from aerosols because they're not particles at all. They're just individual molecules mixed in with all the other molecules that make up the air. You can't see them, you can't feel them, but their impact can be massive. And whoa, okay, just take a look at this table. This gives you an idea of just how huge and varied this category of pollutants is. It's a massive list, broken down by chemical family, everything from sulfur compounds all the way to radioactive compounds. Let's just try to break that down a bit. You've got sulfur compounds, you might know them as a key ingredient in acid rain. You've got nitrogen compounds, a huge component of vehicle exhaust. Then there are oxygen compounds like ground-level ozone and the deadly carbon monoxide. And the list just keeps going. Each of these families has its own unique sources and its own unique dangers. Let's just zoom in on one of these to make it real. Sulphur dioxide, or SO2. This gas is a major league pollutant worldwide, and it mainly comes from burning fuels that are high in sulfur, especially coal used in power plants. It's the perfect example of an invisible gas that causes enormous environmental problems. All right, so we have our main categories: natural contaminants, aerosols, and invisible gases. Now it's time for the final piece of the puzzle. Where does all the man-made stuff actually come from? Let's connect these scientific classifications back to the real-world activities that create them. This next table is fantastic. You can think of it like a pollutant source map. It shows you the specific pollution fingerprint for all sorts of human activities, from manufacturing to power generation. It tells us exactly what kind of junk each industry tends to kick out. Let's just pull out two examples to see exactly how this works. You take combustion, which is basically just burning fuel, and you get that classic mix of dust, smoke, and gases like sulfur dioxide and nitrogen oxides. But then, compare that to petroleum operations. They also create dust, but they also create mists, and their gas profile is totally different. You get things like hydrogen sulfide and those really smelly mercaptans. Every process has its own unique signature. So you might be thinking, okay, this is a lot of science, a lot of categories. Why does this matter so much? Well, it's actually simple. You cannot fix a problem you don't understand. The technology you'd use to capture big dust particles is completely useless for scrubbing an invisible gas from a smokestack. This kind of scientific breakdown isn't just for academics. It's the absolute first, most essential step to figuring out how to clean up our air. We've seen the big industrial sources. We've broken down the science. But here's the final thought I want to leave you with. It's easy to look at this map and point to a giant factory. But from the cars we drive, to the electricity we use, to the products we buy, our own daily lives are deeply connected to all of these processes. It really makes you stop and think, where do my own actions fit on this map?